Okay, this is a continuation with the rest of the questions from section 2.4 in Mathlinks on rational numbers and square roots of rational numbers. Question 9 says, is each of the following a perfect square, and explain? So in question A, it gives you the fraction or the rational number in fraction form 1/16th. And what you want to ask yourself, if it's a perfect square, then it will have a square root that's a terminating decimal, right? Or a repeating decimal. It won't have an irrational square root. So if I'm asking myself what fraction multiplied by itself was 1/16th, if your numerator, in this case 1, is a perfect square, and your denominator, in this case 16, is a perfect square, then the fraction itself will also be a perfect square because 1 times 1 would give me a numerator of 1, and 4 times 4 would give me a denominator of 16. So therefore, 1/16th is a perfect square because its square root is a quarter. So if I was to change this, instead of fraction form, change it to a decimal form and say, well, what is 1/16th? So 1 divided by 16 is 0.0625. So 0.0625 is the same question, but in decimal form rather than fraction form. And if I say, what is the square root of this? It should be decimal 25, right? The square root. And it is decimal 25. So the square root is 0.25. Or in fraction form, the square root of 1/16th is 1/4. For B, the square root of 5/9, is it a perfect square? The answer is no. And the reason why is because, just what I said in the last question, for the denominator, it is a perfect square because 3 times 3 is 9, but there is no numerator that multiplies by itself to give you the whole number 5. So therefore, 5/9 is not a perfect square. Now for C, 0.36, back in the very first question that we did with the 3 people that did the square roots of numbers, since 36 is a square number, it appears that the square root of 0.36 would probably be as well. But that would be the same thing as saying, well, then therefore this would probably be a perfect square, and this would probably be a perfect square, etc., etc. But what we do is when you have it like this and you need to solve it without a calculator, you need to convert this into the square root of the same rational number, but in fraction form. So we have 36 hundredths. This is 36 hundredths. Hundredths, which in fraction form is 36 hundredths. And therefore, what fraction multiplied by itself is 36 hundredths? Well, since both numerator and denominator are perfect squares, 6 is squid. So that's the worst place for 6 ever. 6 and 6 is your numerator, and 10 and 10 is your denominator. So therefore, yes, it is, and the square root would be 0.6, or converting it back again to decimal form, 6/10. And finally, the last question, just like question C, it seems like the square root of 9/10 would be a perfect square because 9 is a perfect square, 3 times 3, and it seems like 9/10 should be. But when I reconvert it to the square root of its fraction counterpart, I know that what fraction times itself is 9/10. Well, the numerator in this case is a perfect square, but the denominator is not, and therefore, no, it is not a perfect square. Question 11, what's the square root of all of these numbers? Evaluate. So it does not ask you to estimate. So for these questions, if you wanted to solve it with a calculator, of course, you could just plug it in. But what number multiplied by itself for A is 324? Or sorry, not 3.24, but 324. Well, since I know, if I'm thinking about number line, I need to know my square roots past 144, and that's pretty tough. Let's see if we can figure 17 times 17. Let's just go here. 17 times 17 is 289. So 17 squared is 289. 18 squared. Oh, I wonder if that's right on the line. I bet you it is. 18 squared is 324. Look at that. 324. So therefore, it's 18 times 18. I did that without actually hitting the square root button. So therefore, the square root of 324 is 18. The square root of 289, well, we just did that when it was 17 times 17. So if 17 times 17 is equal to 289, I bet you it's going to be something like that. So let's look at this as being, instead of a decimal, let's look at it being 2 and 89 hundredths. This is the same question. And if you were given a mixed fraction and you want to do it without a calculator, you need to convert that to an improper fraction, which would be 289 over 100. We just did 289 was 17 times 17. So therefore, what fraction multiplied by itself is 289 over 100? Well, both numerator and denominator are perfect squares. So 17 and 17, 10 and 10. So therefore, the square root of 289 over 100 would be an improper fraction, 17 tenths. As a mixed fraction, 1 and 7 tenths. And as a decimal, 1 and 7 tenths. And I know that was a pretty long stream of thought, but if I go back to my calculator and say, what is the square root of 2.89? Square root, it says 1.7. And conversely, or inversely, 1.7 times 1.7 is 2.89. Your next question is in decimal form. It says the square root of tenths, hundredths, thousandths, 10,000ths, 225 10,000ths. Ooh, I think this is going to be a dandy because both of those are perfect squares. What fraction times itself is 225 over 10,000? Well, what number multiplied by itself is 225? The answer is 15 times 15 is 225. And what number times itself is 10,000? The answer is 100 times 100. So therefore, the square root of 225 10,000ths is 15 hundredths. And therefore, the square root of this decimal here is also 15 hundredths, or 0.05. Double check with the calculator. What is the square root of decimal 0.225? Square root button. It is 15 hundredths. And finally, what's the square root of 2025? Well, this is getting way beyond my pay grade because I do not know my perfect squares beyond 20 times 20 is 400. But if I think about 30 times 30, that's 900. 40 times 40, that's 1600. 50 times 50, that's 2500. So I know that it has to be 40 something, right? 40 decimal something. And since it ends in a 5, my guess is 45 times 45, because that's the only way I can end up getting a 5 at the end, I think. So if I go and take my calculator, wouldn't that be great if 45 times 45 is that 45 times 45 equals, oh, Bob's your uncle. So therefore, the square root of that is 45. Question 12, it says calculate the side length of each square from its area. So if you're given this, first thing you should probably do is draw, oh, that's not 8, it's a 9. 169 meters squared. And in order to get the side length, this is a Pythagoras question. Back in grade 8, you learned if you're given the area of a square, its square root, so the square root of 169 will equal its side length, or area equals side squared. 169 equals s squared. If you square root both sides, the square root of s squared is your side length, and the square root of 169 is 13. So therefore, what is your side length? It is 13 meters, because the square root of a square's area is its side length. And finally, draw the picture for this one. I'll even make it smaller to keep it to scale. 16 millimeters squared, so therefore the square root of 16 hundredths is the same thing as the square root of 16 hundredths, and therefore 4 tenths times 4 tenths is 16 hundredths, so therefore it's 4 tenths millimeters. Double check, of course, with a calculator. What is the square root of 16 hundredths? And it is 4 tenths. Question 13 says estimate each square root, then calculate it to the specified number of decimal places. So the first one says the square root of 39 calculated to the nearest tenth. If I think about the benchmarks that it's between, the square root of 36 is perfect square of 6. The square root of 49 is perfect square root of 7. So 39 would be 6 decimal something. I'm going to guess it's around here. So my estimation to the nearest tenth will be roughly 6 decimal 3, maybe? 6 decimal 3, approximately 6 decimal 3. Take it with a calculator. I'm probably off, but who knows? Square root of that is 6 decimal 2. So close, but you know what? That's close enough for me. The next one, 4.5. if I say what is the square root of 4 on my number line, that's 2. And the square root of 9 would be 3. So the square root of 4.5, well, that's really close to 2. So it says the nearest hundredth, I don't know, let's go with 2.13 as my estimation. So my estimation is approximately equal to 2.13. I don't know, maybe. And if I take my calculator and say, what is the square root of 4.5? It's 2.12. I was so close. So close. The actual closer calculation is 2.12, but my estimation, me and Dem, or the calculator, it was pretty close. For C, the square root of 0.87. If I think about my number line, well, this one I kind of know, because this is 87 hundredths, and I know the square root of 81 hundredths, because we did it in the question before, is 0.9, and the square root of 1 is 1. So the square root of 0.87, oh, on this number line is going to be somewhere around here. So if I add a couple insignificant zeros, because I need to go to the nearest thousandth, right? It's probably 0.978. Let's just make it up some kind of random number. So square root of 0.87, I'm going to guess, my estimation is 0.978. That's me. And Dem, the calculator, what is the square root of 0.87? Boy, if I'm close, this is going to be amazing. Oh, I'm way off. 0.932 is equal to 0.932. How come I was so off? Oh, I know. Oh, I know why I'm so off. Because my 987 should have been, see, this would have been, right in the middle would have been 0.9. So mine 0.987 should have been more over here somewhere. Yeah, I was way off on that one. Oh, well, you get the idea. And finally, D, the square root of 22 thousandths, or the square root of 22 thousandths. So for this one, the good news is neither the numerator or denominator is a perfect square. But if I was to guess perfect squares that were between there, if I think about a fraction that is kind of close to, well, let's make a perfect, 25, my perfect square up top, and let's make 900 down below. So the square root of this fraction is kind of close to 22 thousandths. So therefore, what fraction times itself is 25 900ths? That would be 5 on the numerator and 30 on the denominator. All right, so because 5 times 5 is 25. So in lowest terms, this would be 1/6. And 1/6 is approximately 0.16-ish, right? If I was to convert that, because I know my fraction is pretty good. So 1/6 is 0.16, or roughly, if you got 1 to the 6 on the test, you got 16.6%, right? So I'm going to estimate it. It's be amazing if I'm actually close. That's being 0.16. Now, if you couldn't do that, that's no problem. That's a pretty complicated one to estimate. So probably in these cases, you're just going to grab your calculator and put the square root of that in. 0.148, 0.148, 0.148. This is the calculator. So I was not far off with 0.16, and it's a pretty good guess.